So hello everyone, welcome to Intellipaat's live webinar on creating chatbot using Python, NLP and data science. So today's webinar will be conducted by Mr. Ankit Tanmay, who is a senior data scientist with 8 years of experience in providing data-driven solutions to complex business problems. So presently, he is working in Microsoft as a data and applied scientist. So guys, let's welcome Mr. Ankit Tanmay into the session. Sir, over to you.
Hey, thanks. Thanks for this warm welcome. Thanks everyone for attending the session. It's really great to meet and participate in a session like this where I can interact with the enthusiasts of ML, at the same time the experts working in this field, and learn from them and share my learnings with them. So thank you. Let's get started. In the session today, we are going to talk about chatbots, and I would like to use both code at the same time, PPT, to talk about chatbots. I would try to cover the concepts in the most lucid manner possible. So if in case you have any doubt, but I would also be cautious about the time and the amount of content to cover. So let's get started. I hope you will have an amazing session focusing on your career and learning about chatbots, which is one of the most amazing use cases of machine learning and AI that I have seen and I have worked with. Welcome to chatbots. Chatbots, as I have mentioned on the slide, is basically an example of AI in action. I am going on slideshow mode from this slide. So this is the agenda of the session that we are going to cover today. We will talk a bit of brief on chatbots. Then we will cover what is the need for chatbots, some types of chatbots. Then we will talk about rule-based chatbots and self-learning chatbots. And not just that, we are also going to delve deeper into the coding side of developing a chatbot right here, right with you all in Python, and second using Python and NLTK. With this agenda, let's start about chatbot. So I copied this line from Wikipedia, and it pretty much explains what exactly chatbot is. A chatbot, according to the definition on Wikipedia, is a software application that is used to conduct an online chat conversation via text or text-to-speech, and it provides a direct contact with a live human agent. And this contact is established between a machine and the human, who is generally a customer. So this intelligent piece of software application is one of the most cutting edge use case of AI these days. And a lot of software companies implement chatbot in their day-to-day interaction with their customers or consumers. These companies generally have, have chatbots that interacts with these customers and resolve their problems, which in ideal scenario will take a fleet of customer service executives to handle and to work with. They cut down on the cost, they save a lot of time, and at the same time provide an amazing experience to their users through this intelligent and sophisticated piece of AI. Chatbots make all these things possible. It all started in 1966 when the first chatbot called Eliza was created. And the manner in which Eliza was created is still used today by the people who are the chatbot designers of today. And they still utilize the same infrastructure, same architecture, or infrastructure in developing the chatbot. Chatbot, as I mentioned to you, is an AI, and an AI's efficiency is measured by something called as Turing's test. So Turing's test is the criteria that checks or evaluates how close is a code or a piece of software towards a real human. And Turing test was first performed on Eliza, and it was one of the first test use case of Turing test. And these days, with a lot of deep learning and a lot of cloud and sophisticated computing coming in, we have reached sufficiently good accuracy and very high score on the Turing test for the chatbots that are getting developed these days. A lot of amazing chatbots using cutting edge research that is happening in text analytics field through BERT model, through sequential models, have made all these things possible. How exactly ELIZA was created, right? With this background, let me tell you what we are also going to do today in this session. So ELIZA's key method of operation involved recognizing keywords or phrases in the input, and it used to output the corresponding prepared or pre-programmed responses so that it can move the conversation forward in an apparently meaningful way. By doing this set of three operation, like it first used to recognize keywords, and then it used to match the user provided input to the keyword dictionary that it used to have, and it had a set of pre-programmed responses for each of these keywords. That is, it used to return back to the user so that it can move the conversation forward in a meaningful manner. These sequence of steps were copied by chatbot designers even after Eliza. And even today, chatbot designers perform the same sequence of steps in order to build or develop the sophisticated piece of AI. Now, the need for chatbots. The application of chatbot is so infinite that several companies use chatbots for their internal and external use. Three most commonly used areas where companies are using chatbot today is messaging apps, for customer service, and for company internal use. Right now, with WhatsApp in business and Telegram allowing businesses to interact with their customers directly, many of the companies have developed Telegram bots or WhatsApp bots or even Facebook Messenger bots to talk to their customers or to talk to their consumers. I recall when I was a kid, there was an app which was pretty popular. It was called HiCap, and there they had a very intelligent bot called Natasha that can interact or chat directly with the users. You can also ask Natasha cricket score, and it would tell you the live cricket score. So a chatbot like Natasha, which is intelligent enough to understand what you are saying, the string of text that you are passing, and it used to take that string input, parse it, understand it, comprehend it, and also give you a response in a manner that will make you feel as if you're talking to a human. Another chatbot or a sophisticated bot that we see all around us is Alexa, which is very popular. Many of us have either Alexa at our home or at our friend's home, or have interacted with Google, Google Assistant, which is also a chatbot. Most of us using Android mobile phone has have at least once or twice interacted with Google Assistant and said something that turned out into a meaningful conversation, and we realize that hey, it's actually very intelligent. So all these intelligence is fueled by machine learning, AI, and uh, with this we have become capable of replicating what humans previously used to do at much ease and at scale, so that everybody can make use of it, and everybody can leverage with this technology. In customer service, we have interacted with Swiggy bot, Zomato bot, even Vogo bot. I was using Vogo recently, and I found that Vogo has completely moved out of human-based customer service, and their entire customer service operation is on Vogo. Yeah, Mohammed, even I miss Natasha. It was really, really beautiful application. Nice. Also, many companies, right, who have very huge workforce, many of the service-based companies, in fact, product-based companies employing thousands of people, also use chatbots for their internal use of interacting with the employees and serving the employees answer to the queries, which essentially would take many days to get a response back from the concerned team. So how companies use it? Several HR policies which people generally want to know, they are transformed into a chatbot on the HR portal where employees can ask their HR related questions. Similarly, finance portal generally have today finance bots which can answer your finance related questions. What kind of questions you can expect to get answered when you are using an HR bot? Say for example, I'm an employee and I want to know how many leaves I have pending. So what I can do is I can open my company Microsoft's HR portal and I can type there what is my pending leave balance. And the chatbot will interpret this sentence. It will look back at my pending leave balance and it will revert back to me with the exact count of my leave balance that is pending and that I can utilize. This is a very, quick and easy to see use case of chatbots in a company internal use. Many times when you have business stakeholders who find it more easy to talk to you in terms of English and not in terms of, codes or graphs, and they need quick numbers, you also make chatbot for your internal tool and give it to your business stakeholder. And these managers can easily type a question like, what was the sales last month? And the bot can interpret it and bot can revert back saying that, hey, last month the overall sales was say few $100,000. that is so quick and so easy, making chatbot a favorite piece of technology within and outside the organization, with both consumers at the same time internal stakeholders of a company. Now, talking about chatbots. So, what all types of chatbots? There are many kinds of chatbots, and I have listed down several types depending on their use cases, their way of development. We call them simple chatbots. The first category is simple chatbots. Simple chatbots, they have limited capabilities and they are usually based chatbots, and they are very task specific. Then we have some smart chatbots. They are also called retrieval chatbots. These chatbots are AI enabled and they are designed to stimulate near human interaction with customers or with the end user. Then we have hybrid chatbots, which is a combination of both rule-based at the same time AI chatbots. Then, as I told you, we have social messaging chatbots too. And then we also have menu-based chatbots, where you have found or encountered menu-based chatbots. Can you guys recall? Menu-based chatbots, by definition, will give you a menu of options, and you need to choose one of the item in the menu. Amazing. Amazon is one such example. Also, Swiggy. When you complain on Swiggy, it asks you, from a set of menu, asking what exactly is your problem. Why are you trying to reach out to the customer executive? You can say, hey, you know what, my food is cold. You can say that the delivery executive delivered the wrong item, or you can choose any other option available from the menu to continue the conversation or keep the conversation flowing. So these are menu-based chatbots. All these chatbots, they have their specific use case. Menu-based chatbots are used when you want to segregate the conversation and pass it on to a human eventually, which will continue the conversation based on the specific choice or specific kind of problem. Say, for example, if my problem is concerning the delivery executive and I need a special human attention, so I will already have filters in terms of the menus, which will keep the conversation flowing. And essentially, it will identify that, hey, you know what, this user has a problem related to wrong delivery, and hence it should go to the, yeah, correct. It should go to the human customer service executive. Yep. In service sector, you have these menu-based chatbots to further segregate the reason why exactly you are having, you are interacting and you are chatting for, you're seeking out for help, or you're chatting with the business. Post this, the main category that we are interested in looking at today is, is a set of two chatbots, rule-based chatbots and self-learning chatbots. Now, self-learning chatbots are also called reinforcement chatbots and, retrieval chatbots, my bad. And they retrieve the information that they have learned from and they answer the user. Whereas rule-based chatbots, they basically have a set of rules based on which they post their reply to each and every user query. To dive deeper and to talk about the segregation in much more elaborate manner, I will read out the 4 bullet points that I have here to make it clear to you guys what exactly a rule-based chatbot is. And similarly, I will read out self-learning chatbot. Post that, I will stop and then I will talk about the chatbot architecture, and then we will look at the code in Python. So by definition, a rule-based chatbot use a set of questions and answers internally entered by the programmer to respond to the request in later uses whenever a user will input his or her query. Chatbots react to questions or statements that match to the database with appropriate answer or action. Then, depending on the context a chatbot is used in, it can be enhanced by adding additional access to external data, such as CRM tables or enterprise systems, ERP systems, and the more resources are made available, the more capable the system becomes. So rule-based chatbots basically have a set of coded rules. By using statistical techniques like like cosine similarity, like term frequency, inverse document frequency, and all these statistical techniques make the self-learning chatbot learn from the interactions that it is having with the user, at the same time from the corpus of text which is provided to it. And it becomes so intelligent that many times it's so difficult to distinguish that you're not talking to a machine but talking to a human in general. So bots that use machine learning algorithm to learn how to provide suitable answers to unexpected questions are called self-learning chatbots. And trust me, these chatbots often can handle unexpected questions too that you have not thought or coded as a rule in the rule-based chatbot, giving you a seamless near human experience. A chatbot of this kind is artificially intelligent, and by learning from past interaction, the bot also grows in scope. It can then answer not only questions it was previously trained with, but it can also answer unexpected questions. And this method leads to far more capable and sophisticated chatbots. But at the same time, it also require efficient compute on which you will be running it. Narayanan, the example of self-learning chatbot is basically the bots which we generally read in newspaper developed by Google that can also program itself, or the bots which Facebook generally develops and we read about it in newspaper that can mimic human emotion, or even even start talking about sophisticated human emotions like depression, or sadness, or grief, or happiness. So a self-learning chatbot. Oh, examples of rule-based chatbot. Very simple. You have rule-based chatbots in your basic menu-based chatbot apps that we see in Swiggy or Zomato. A rule-based chatbot I will code right in front of you today, and we all will code it together so that we can learn about how rule-based chatbot is created and it works. Rule-based chatbots are generally seen on Swiggy when you interact with Swiggy and you type hi. So a rule corresponding to every hi will be to greet back. So a rule-based chatbot will essentially fetch in the word hi, see if what you have written is hi or bye. And based on the response, based on the interpretation of the input that you are giving, it will generate the response to you. So when you will enter hi, it will reply back with hey. How is it different from answering machine? I'm not sure what exactly is an answering machine. I have not seen answering machine. Cool. So when you make a machine talk to you, it's a chatbot. An answering machine, I'm assuming, is a chatbot too. So I don't know how different, in what sense you are going to ask. Not very clear. Cool. So basically, in any chatbot you make, be it an intelligent chatbot, self-learning reinforced chatbot, or be it your, rule-based chatbot, these set of steps is pretty evident and it is prevalent. If I move this on the side, it becomes more clear to you. So basically what happens is at the beginning, there is a user message. The user message is then interpreted by the compute on which your code is running. And on this, the user message is passed to capture two information: intent classification and entity resolution. Intent classification will basically evaluate what is the intent, and entity resolution will basically evaluate if there is any individual present in the text or talked about in the text, or any object or any place or any particular kind. Say, for example, when I enter and start the conversation with my bot and I type hi, the intent is I'm creating the bot. And if I, instead of saying hi, I type bye, my intent will be I'm ending the conversation with the bot. So intent classification step will basically evaluate what is the intent of the message by the user. Entity resolution step, on the other hand, will resolve the entities that is present in the sentence that a user has passed. Then once the intent and the entity is, is segregated, it goes to the AI brain or the brain of the algorithm, and then a response is selected with the highest similarity, and it is passed as a response by the bot to the user. Now, with this context, let's see if we can make a rule-based chatbot. So I'm switching away from the presentation and I'm opening one of the Colab notebooks with which we can uh, develop or start developing the rule-based chatbot. I have created this already for you, but I will also be working on, on developing this in front of you in this webinar today so that we are doing it together. For developing this chatbot, I will be using Google Colab. Google Colab is an amazing platform that allows me to run Python code and to demonstrate, all the capabilities of ML and AI to you. Let me create a new Colab notebook and let me call it rule-based bot demo. Cool. As I have told you, and as you can recall from the slide which I was showing, Basic flow will be to classify the intent once I have received the user message, classify the entity, go through the brain, and then select a response for every user query and go on with the conversation. So for doing this, what I'm going to do is I will develop this very basic Python-based chatbot. I'm going to use two standard libraries in Python called re, and I'm also going to use random. So random library basically allows you to choose one of the response. It generates random numbers basically, and it also allows you to choose a response from a set of responses present in a list at random. Re is by default the string handling library that allows me to perform several string operations like searching, like subsetting a list, or string matching, etc. Using these two libraries, I'm going to, and also the native capabilities of Python, I'm going to build a rule-based bot. For this, I start by creating a class, and all my functions for the rule-based bot will be inside this class. So I'm calling it as rule bot, and I am defining the class. So once I have declared rule bot class, I will start by creating a list of potential negative responses that user can generally give. Now, what these potential negative responses are, uh, I want my bot to learn from this from the list of negative responses. What should be the response the bot will provide when the user will pass any of these negative response? And these potential negative responses can be something like no, nope, nah, no, not a chance, sorry. So I will copy these negative responses and I will paste them in order to filter for negative response. Similarly, I will be keeping a list, I will be creating a rule that will know when to exit the conversation. Exit conversation keywords. These keywords will basically be the exit commands that will mostly look like quit, pause, exit, goodbye. Okay. Then I need to have a set of starter questions, random starter questions, so that the bot can start continuing the conversation with the user. These starter questions are pretty generic questions that makes the user feel as if it is continuously talking to the bot. And I have already created a list of few questions with which we can have the conversation flowing. All these will make sense to you once I am done putting everything in place. After this, uh, I will declare the init function and will pass self as a parameter. Inside this, I will be coding the logic of the entire bot. Now, I will call this bot as, so the context is, imagine this bot as an alien that came on this planet and it started talking to you. Given it's alien, it doesn't know many things, but a few rules that it has learned from the dictionary which was available to it in its planet about humans. So what this bot has done is it came on this planet and it know a few negative responses, knows a few exit commands, and knows a few random questions. And also it has some context about three areas. Now, what are these three areas? These three areas are basically, it has context around knowing about the planet on which it has landed. It has context around knowing why, and it has context around Intellipaat. What exactly is Intellipaat? And it also knows what to say when none of the intent matches. So basically, four cases are present for this rule-based chatbot. Now, what I'm going to do is I'm starting the development of this chatbot by creating these three intents. All right. Under the init, I am declaring a method, and I am saying the three main keys as the dictionary describe planet intent, and it will have any string that ends with your planet. Then we have answer why intent, and it will involve any string that user will provide having keyword why. And any string that user will provide having keyword Intellipaat will get segregated as about Intellipaat intent for this simple rule-based alien or bot that we are creating right now. Then I'm declaring another function called greet. With this function, the alien or the bot is basically going to greet. and I am defining it as basically it starts by asking what is your name, and then it will um, it will ask for help from the user by taking the input by saying, hey, whatever is the user provided name, and it will say, I am a robot, will you help me learn about your planet? And if this will have any of the negative responses, then it will terminate the conversation by saying, okay, have a nice day. Now what I'm coding here is essentially a rule, and these rules are coded in form of if else condition. You can see here, right? And if is making the conversation flow. It will become more clear to you once I will run the bot and show you how these functions work in action. Let's hold on for a few seconds and let me explain some of these functions to you, while I am preparing this entire rule book. Now I have written another function called make exit, which basically say exit, and it returns which basically invokes the exit step in the bot, and it does so by returning a statement called okay, have a nice earth day, and it exits the entire bot flow or the conversation. For this, the user should have any of the keywords present in exit commands list. So what was my exit commands list? It were a set of words inside this tuple like quit, pause, exit, goodbye, bye, and later. So whenever any of the command from the user matches exit command list, it will return by typing the statement, and it will return as true. This is for handling the exit scenario. For greeting scenario, we have already written the function. Then we have a chat scenario where the bot will continue having chat with the user. Now, how this chat scenario is coded, let me show it to you. So inside this chat scenario, we are looking at the reply which user is making, and based on the reply, it is going to it is going to check if it needs to make exit or not. If it doesn't need to make an exit, it will match your reply with a match reply function. Now, where exactly is my match reply function? I will type my match reply function later here. In this match reply function, what I am doing is I am in the match reply function, what I am doing is I am iterating through the list of items that I have declared in this alien babel dictionary, and in the alien babel dictionary I am checking for a pattern match. So using a re.match, which is basically a string matching step, I'm checking what should be the reply type depending on whether the match is between any of the three intents that the user is having when asking or talking to the bot or to the alien. Now, the user's input can be either classified into describe planet intent, or it can be classified into answer by intent, or it can be classified into about Intellipaat intent. And using this set of code for key comma value and self dot alien babel dot items, I'm evaluating the intent key. I'm checking the regex pattern, and if the match is found and intent is found as desirable planet intent, I'm returning using the method of desirable planet intent. If the match is found with answer y intent, I am returning using the method answer y intent. If the match is found with about Intellipaat, then I am returning about Intellipaat intent. If no match is found, then I am returning with no match intent. So basically, this bot has learned four rules. It can learn not just four rules, it has also learned two additional rules about greeting, like how to answer to hi, and it has also learned about how to answer to bye or quit. So basically, 4 plus 2, 6 rules. 6 rules is what is coded in this rule-based chatbot. Now, I'm declaring what exactly each of these, intents will be. So right below, pasting them for you. So describe planet intent. My bad. Let me do a shift tab, else Python will give me an error. Yep, perfect. Describe planet intent. So what is happening in describing planet intent? So when you will ask any question about this alien, about his planet, it will generate a response to you these from one of the two values present inside this tuple. And using random dot choice, I am randomly choosing what should be returned as a response when you will ask any question to this bot about it. its planet. Answer why intent will return you any of the response from one of the values or one of the sentences in this tuple. And what is why? So say suppose you are asking this question to the bot, why you are here, or why do you want to talk to me? Then you can add as many rules as you code. The limitation is your thinking capability. If you think of all the possible questions which user can ask, you can just simply put it as an intent and I can do it right in front of you, Pavitra. I will show you just like I created about Intellipaat, I will show you about Pavitra as a new intent and I can show you that the bot will learn from your intent as well whenever user will ask any question that will have a keyword matching Pavitra. So the limitation here is you cannot keep on typing so many things or so many lines of text or so many rules inside the bot. You basically want it to be intelligent enough to learn from a given block of text and to answer accordingly depending on the user response and the nearest matching value that you have fed the bot in the text. So with these intents, finally, I am going to invoke the rule bot, and I am going to start by saying the bot to greet us. So are you ready for action? As I've told you, Python is indentation sensitive. Yes, I fixed the indentation and here we are running the code. So what is your name? You remember the first thing which I have in the greet command is what is your name. So let me explain the flow. When I called alienbot.greet, so the greet method inside this class gets invoked. And what is the first step inside greet? It is to take input by asking your name. So if I enter my name, let me use Pavitra's name, Pavitra, and I enter her name. It gives you a response. Hi Pavitra, I am a rule bot. Will you help me learn about your planet? Pavitra, can you see it? This is one of the rule that we have coded in this bot, that when input will be your name, it will reply with this response, hi, self.name, basically your name. And then it will say, I am a rule bot. Will you help me learn about your planet? And here, if you will type a negative response, say you are a bad person. I hope you're not, but just for fun. So no offense, please. I say no. Okay. Then it is asking me what technology do you have on this planet? Let's say I call it data science. Please tell me more. Data science. It is asking you more about data science. Data science is about making machine learn things and get insights from data. See, wow. Then it is asking why. You can say, I don't know. No, it will quit in the third step. If I say, nah, what was the negative response? What was my negative response? No, nope, nah. Okay, let me put nah. Why do you say that? Nah. Oh, okay. Where exactly negative response? Negative response, negative response, negative response. Looks like I didn't code negative response to quit, and hence it is not quitting. It is keeping on asking the questions. If will help in negative response. Now, will help is input. It should quit by saying, okay, have a nice day. Nope, it's not flowing through the oh yeah, no, it's not flowing through the logic. Cool, no worries. I need to call this to quit. Declare it separately for the conversation or for the sake of this session right now. I'm going to keep it simple. Let me show you by saying what happens or what is this bot capable of. Let's iterate through each of these three scenarios or each of these intent. And let me first talk about asking the bot about its planet, right? So can you tell me more about the planet? And if I type this, what is the response? It is asking me, please tell me more. What is the keyword that it needs to take? Detect planet intent, your planet. Cool. Have a nice Earth day. It did quit. What is your name? Let's again start the flow by typing Pavitra. Hey Pavitra, I'm sorry about using your name. Okay. Sure. Does Earth have a leader? Yes. Tell me more. Narendra Modi or Donald Trump? Interesting. Can you tell me more? What more? Let me type by saying nah. Oh, cool. So the flow is broken. I'm sorry, Sashivanan. So I need to change the flow uh, of handling the negative response. But let's check if it interprets Intellipaat. Yeah, it does. So when I type Intellipaat or when I ask it, can you tell me about Intellipaat? It is going to return one of the response from the set of responses that I have coded, and I have coded in Intellipaat that whenever it will detect the user input and the user input will have anything with Intellipaat as the ending word, it is going to go inside this logic and it is going to return one of the three responses from the response tuple that I have created at random by choice. Again, let me again ask about why. So let's ask something related to why are you here? Why are you here? Oh yeah, you can be precise. You can code it to be precise and you can code it to have a random. If I don't use a random dot choice, but I always return a single value. Say for example, in this string of Intellipaat about Intellipaat, if I always say return Intellipaat is great place to learn, it will always return the same response. Let me first quit the execution and I quit the bot by saying, okay, the bot quits by saying, okay, have a nice day. And this time I again initialize the bot. This time I will use my name and yes. And here instead of chuck it, chuck it and tell me about Intellipaat. Let's see. Intellipaat is a great place to learn. If I will repeat this, given that I have removed that random statement each time, it will return the same value. So you can also hard code it to always return, the same value. I forgot Pax last time. Yeah, okay, cool. So I hope I answered your question. But what I wanted to demonstrate with this piece of code is a rule bot. So say if I type rules, yeah, it is going to, are there many humans like you? I say, yeah. I see, can you elaborate? So people like people. Nice, please tell me more. So you see, basically, when you don't have a match, essentially goes inside this set of, this set of tuple and picks a random string from the set in order to continue the conversation. You can create additional intents by doing what? Say, for example, if I want to create a new intent, right? Let me stop the execution here. And I want to know about, say, about session. All right. And I want to, is there any possibility of two rule about chatting on behalf of humans? Yeah, but what will they end up with? See, they won't be learning anything new, Durga Devi, because they won't be, they are not, they have their rules hard coded. So when you do the same chatting between two AI bots, they will have cross pollination of learning between them. But a rule bot, the rules are already fixed. So they won't be learning something new. Rule bots, the rule you define. Like I define what all random questions the bot will ask. I define what all, resolutions it can make. It can make a resolution about planet intent, Y intent, Intellipaat, about session. And I also define the flow in which the code will execute. I define when it will exit. I define when how it will handle the negative command. I define how it will handle the positive intent or how it will greet or what it will say when it will terminate. All these things I define in rule based bot. So the rules that I code are only the possibilities of the bot. And in front of you, I will be coding another rule. To answer your question, you can have two rule bots chatting on behalf of humans, but only when they have a specific business use case. If you don't have any use case, there is no point. Say, for example, in your company, you can create a rule bot that will talk or raise a PR, or raise a error PR whenever there is any bug detected in code that you have obtained from any of the third-party vendor who is providing you any software application. So you found the bug and you raise a PR, and the bot raised the PR on your behalf in the vendor's system. Now the vendor is also intelligent, and it has instead of having a customer taking the PR, it has also installed a bot that will take in customer problems. So that bot will read the response which your company's bot has generated in form of PR, and that bot will maybe reply to your bot saying that, hey, thanks for raising the PR. We will get our engineers working on this shortly. So this is one possibility or one business use case when you have two bots chatting on behalf of humans. But in general, if it is not a self-learning bot, these two bots will not have any cross pollination of information and learn from each other. Rule-based bot, there is no cross learning. The rules are already hard coded, and the bot is only responsive based on the rules that is present or coded by the programmer. So let's talk about session. So anything that has got, say, R and dot star apostrophe S star and session. Okay. So let's say I declared an intent called about session, and I'm defining what exactly will happen by this session or this session queries. So I again created another function, and I will copy the code which is here. No, I won't be copying this. I will be copying the choices. Okay. And I will have two responses, right? What all these are, what two responses I want to code? Oh wait, am I following the intent right? I think I need to press tab again. My bad. Okay, cool. So responses about session whenever somebody asks about session. So session is on, what is the date today? 14th August 2022. And second thing, or you can reply by saying session was cool. Cool. And any of the random choice. Let me again trigger the alien bot and let me answer by saying whose name? Let's say Durga's name. Okay. Durga. Durga, can you help him know about your planet? Yes. What do you consume for sustenance? Okay. Food. But can you tell me about session? Okay. Now. Oh, yeah. Okay. Oh, the flow got broken. Wait a second. About session. Where exactly? About session I have coded and return random dot choice. Oh yeah, I also need to code this in match reply. Cool. So in the match reply, I will have another elif saying found match and intent should be about session. Cool. Now this exactly is how the logic is coded. Am I making sense? Are you guys able to follow? Cool. Again, let's start by saying Durga. Yes. Can you tell me about session? Session is on 14th August 2022. You saw this? People who were asking, can we code multiple rules? How exactly you can do it using this piece of code? This is a chatbot. Doesn't it make you feel like you can chat for it forever? Okay, what else? Just type what else. Why do you say that? It is asking why do you say that? Okay, I'm just getting bored. All right, cool. So you just reply, I see, can you elaborate? I had nothing to do since morning. Okay, what else? I see. How do you think? I feel horrible. Okay, please tell me more. Horrible as in not good. Okay, horrible as in not good? Then it asked you why. Because I am tired. Cool. Why do you say that? I did a lot of work, and it will keep on talking to you. This bot will just keep on talking to you until you don't provide a way to quit or terminate the code by typing quit statement. Oh wait, it will take quit lower. Yeah, okay, have a nicer day. So each time the bot expected to read a user message, And whenever user message was coming in, it was classified into the intent. Remember what all intent we had? We had intent about the session, we had intent about Intellipaat, we had intent about knowing more about the planet in which the bot is coming from, we had intent about just random why questions. So intent classification happens based on the intent, and also the entity resolution happens. So when I answer my name, so my name is resolved by the bot, and it greets me by saying hi Durga, or hi Ankit, or hi Pavitra. Is it clear? Depending on these two segregation, there is a logic or the AI brain. Where exactly is my AI's brain? If you will tell me, the brain is basically doing the matching, which of the intent it will follow, and depending on the match, what kind of response it should give or deliver, if it should be random or if it should be continuously the same response all the time. This essentially becomes my AI brain, and post this a response is given to the user. And response with higher similarity is the case when you are making a bot that I'm going to talk next, which is a Python and a chatbot using NLTK. I hope you guys understood what exactly a rule bot is. You just saw how you can make Python or a code talk to you in a very simple and very easy manner. Interesting. This exactly is what you can do. And imagine what all things are possible when you will implement in your own organization or within your organization. Say, for example, in Microsoft, I work for a team. And in my team, a lot of people use different dashboards. Suppose, say, for example, somebody tells, from the dashboard, find me what was the performance of, say, Word application across the North American geography. What I can do is, whenever user will type a command, like, let me again show it to you by running the bot, right? And let me make it real to you. Instead of what is your name, say, for example, I can use it for, saving the user's query in the database. Say, for example, my senior or my manager is using, and his name is, say, XYZ. So it tells me XYZ, right? My manager name. What I will do is I will save this conversation under his name to the database. Now, instead of will you help me learn about your planet, it can type a statement, say, what is your query today? And say, my boss wants to know about the performance of office in USA, right? What will happen? Instead of printing, why are you here? I can detect this keyword saying performance and office and USA and write a SQL query. And that SQL query will in turn hit the database, fetch the response, and I can, instead of returning, why are you here? I can return the same sentence with the value from the database that I have fetched from the SQL query. This was your rule-based bot. Again, talking about bots, AI bots, comes an intelligent bot. Great. So another chatbot is retrieval-based chatbot. So in retrieval-based chatbot, what happens is you need not code the rule. So you saw me coding each and every rule about session, about Intellipaat, about planet, about whatnot. What if, what if I don't have enough time to code about everything, but I want to use machine learning and AI to fuel my chatbot so that the chatbot automatically learns from all the internet and becomes so intelligent that after learning from everything which is present on internet, that it will tell me the right answer to every user query or everything that the user is asking. So for this, we leverage a library in Python called NLTK. NLTK is Natural Language Toolkit. Natural Language Toolkit already has a set of libraries that is created for us, which does all these string matching, all the text recognition, and you know cosine similarity, all these things we will be using in order to create a chatbot which is intelligent, which learns from a set of text, and which is going to have a conversation just like, the real conversation that you will have with people who have learned from this field. But chatbot is as intelligent as the learning that you will give me or as the information that it has learned from. Say, for example, if you ask somebody who has not studied sociology a question in sociology, will he be able to answer or she be able to answer the question in sociology? No, right? Similarly, if a chatbot has not learned anything about stars, and you ask any question about star, will it be able to answer? No. So you need to provide your chatbot everything that you can provide and that you think the users can ask. And the chatbot will learn according to this provided information and will have conversation with the user depending on the information that you have fed to him or her. With this in context, I'm going to tell you that the architecture of the chatbot still stays same. The user message will stay same, intent classification will still be performed, entity resolution will be done, there will be an AI brain, but this time this brain will not be a set of if-else condition, but a sophisticated algorithm which will perform machine learning on it, and then it will choose a response, and response will highest with highest similarity will be shared or given to the user. How exactly this entire thing flows? This entire thing goes step by step, and the steps involved in building a chatbot with Python and NLTK can be segregated into five different broad categories. The first is reading the text corpus. What is a corpus? A corpus is a block of text or information that you feed to your bot so that bot becomes knowledgeable. I was telling you, right? If you want to ask bot questions about stars, you need to tell bot what exactly is a star. So collection of text or collection of data is your corpus, Durga Devi. That is correct, right? Then comes the pre-processing steps. In pre-processing step, you have some basics that needs to be done in every text analytics project. Guys, chatbot is an application of text analytics. At the same time, it is also artificial intelligence. So when you are building a chatbot, you are basically touching on both the two cutting edge fields of machine learning and data science, which is AI and text analytics. So you need to do pre-processing, which we generally do in text analytics. And what these pre-processing are, we have stop word removal, and we have lowercase conversion, and many more, like tokenization, stemming, lemmatization. All these things need to be done that we generally perform in the text analytics so that we finally end up with a bag of words. That word can be used to one hot encode each and every information which the user is providing, and based on that we are going to do a similarity of cosine or any other similarity metric to return a suitable response which is very similar to the user question. Now, what exactly is tokenization, stemming, lemmatization? What exactly is stop word removal? What exactly is lowercase conversion? Great. So reading text corpus, pre-processing, what is stop word removal? So there are many words in your sentence that are stop words or filler words. These filler words can be, a and the, or dot, or punctuation. All these needs to be removed from your sentence so that your sentence is way more, rich in terms of the information that it has learned. Then it also used to do every sentence conversion to a single case. Either you can keep everything in uppercase or lowercase. This is essential step in text analytics because uppercase is treated differently compared to lowercase in text analytics. So you convert everything to to lowercase or uppercase so that you can perform string matching with more match accuracy. Then you have tokenization. What exactly is tokenization? I have a diagram here in the slide which basically tells you what tokenization is. Tokenization means to convert a sentence into individual words or tokens. Say, for example, I have a sentence with steps involved in building chatbot with Python and NLTK. Each of these boxes will be one token, or each of these keywords will be one token. Say, steps will become one token. If I make it and move it back. So this is one token. Similarly, involved is another token. Similarly, in is another token. Building is another token. Chatbot is another token. With is another token, and so on and so forth. So every single word is one of your tokens. Then, post tokenizing a sentence, what you do is you do stemming and lemmatization on top of it. Stemming is basically the process of finding similarities between words with the same root. Say, for example, leaf, leaves. Leaves is basically an an a plural form of leaf. So the root of the word leaves is leaf, and similarly, the root of the word leaves is leave, Leav or Leave, right? So Essentially, in stemming, we convert every sentence, every word in the sentence to its basic root form. In lemmatization, what essentially we do is we convert different different variants of the word. Say, for example, leaves, leaves, into the single variant that is leaf. And this is what is the difference between stemming and lemmatization. In stemming, you convert every word to the root word. In lemmatization, you transform the word to its to 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 its root form, to its default form, and then you do the root conversion, or you do a root transformation. Post you do tokenization, stemming, and lemmatization. What you need to do is you need to create or generate a bag of words. Now, what is a bag of word? Bag of word is a collection of all the words. Post you have done standardization. Post you have cleaned your text for stop words. Post you have done stemming and lemmatization on your text. Using this bag of words, you essentially convert words into numbers by generating their vector form, or vector, or their numeric form for the tokens that you have created. On these numeric forms, you can implement a similarity measure like cosine similarity to find the most similar sentence to the user sentence or user query that user has inputted. Let me make it real uh, by going and demonstrating a code piece for you. So here is one such code piece, and I'm going to create this code piece using the libraries that I have talked about. Along with that, I'm also going to use two additional libraries for string manipulation, which is string, and random, which is basically for generating a random response. I'm again going to use, use Google Colab for creating this code. And for the data, I'm using a text file called data.txt. I'm going to also tell you how you can create this text file. It is my word corpus. And this exactly is the intelligence, or the knowledge, not the intelligence, but the knowledge of the chatbot that we are building. And you will see here that in this demonstration, I'm not going to write any rule. I'm just going to tell the bot that it needs to return a response to the user depending on the most suitable or most matching information that it has learned in the text corpus. So my text corpus is data.txt, and I created it by opening a Wikipedia page about chatbot. And I will do it twice. Once I will do it with chatbot. Second, I will do it with another demonstration about start, so that you can notice the difference between the two. So for this illustration, I did a control A, did a control C, and what I did, I created a text file called data.txt. I opened this text file and I just pasted everything here and did a control V. So when I did a control V, all these text information around what exactly is a chatbot that was present in Wikipedia. And you remember I told you, right? So chatbots, what exactly is a chatbot and how Wikipedia has defined chatbot. A chatbot is a software application used to conduct. All these things are present here. A chatbot or chatbot is a software application used to conduct online conversation via text. So I have created this text file and I named it data.txt, and I will save this file. Once I have saved this file, what I'm going to do is I'm again going to open my Colab notebook, and I will use upload option in Colab. So this folder icon is where you can upload your information in Colab. You can also read the text corpus if you have a very big size corpus and you have saved it in Google Drive by clicking on this link, mounting Google Drive. And this will mount, Google Drive to you. For now, I'm not going with Google Drive in my demonstration. So you just simply click on upload icon and you find your file here and you just upload it today. So I have it on my desktop and data.txt. I will select it and I will click on open. Open will upload this file and I will start seeing data.txt at the bottom. What you need to do is you need to copy the path. After doing this and copying the path, you need to just, yeah, this line is not needed. Cool. So I will be running these lines of importing library. Once I have imported the library, I will read the corpus. And as I've told you, once you will copy the URL, it will look something like this: slash content slash data.txt, and we are going to ignore all the errors, and I'm going to open this document and read this document. Okay, I have read this raw doc. Let me show you what exactly is raw doc here. So you can see Raw doc essentially is the same thing. ChatBot from Wikipedia, the free encyclopedia, all the sentences that was in my data or in my text corpus is present here. The term chatbot was originally coined by Michel Molden, creator of first Verbot in 1994, and so on and so forth. What I'm going to do post this is I'm going to perform pre-processing on this entire doc. So I will convert every, character or alphabet here first to lowercase by doing raw dot doc lower. And post that, I'm also going to use certain libraries for running my NLTK code. So these three libraries are basically tokenizer. Tokenizer is basically the way of converting a sentence into small tokens, and the punct tokenizer is trained on Twitter dataset. So on Twitter, people generally have very weird way of writing things. Okay, say for example, you can have a sentence saying sush, this is done, right? Will you say these two as two different sentence? No. Yes or no? They are two different sentence. It's such as in you are saying that, hey, you know what? Stop here. And this is done. So these two sentences are very different. Now, a machine needs to be intelligent to learn that these are different sentences. And such this is done can be interpreted very effectively by punct tokenizer as it has learned not just from straight text and straight way of ending sentences and tokenizing sentences, but it is also learned from very millennial way of learning, the one in which people talk in social media or in Twitter. So punct is the tokenizer. Then wordnet is basically a word dictionary. Again, it is provided by NLTK library and already trained for our use case. OMW is another library from NLTK that is going to help me in running my code. And once I have imported these libraries, what I'm going to do is, let me again make it real by putting it, I'm going to run all these things. It will download all these packages. It will convert everything in my raw doc to lowercase. Now, if I will print raw doc to you, everything will be here in lower. See, so raw doc, if I will print, there won't be any capital sentence. Everything is lower, right? Remember, at the beginning, chatbot was C capital. Now everything is lower. Now the chatbot with C capital and chatbot with C small are no different words. They are essentially the same word. Then what I do is I need to convert them into sentence token and word token. Sentence token, I will do using sentence tokenizer. Word token, I will do using word tokenizer that I have imported, right? After doing sentence tokenization and word tokenization, I'm going to end up with list of sentences that is present in my word corpus. For demonstration, I'm going to print two or say five sentences to you. Let's see, these are five sentences which is present in my list. This is first sentence, chatbot from Wikipedia, the free encyclopedia, see chatbot. This second sentence, after comma, a new sentence start, right? Let me close this so that it becomes like easy to read. Where should I place this window? Give me a minute. Cool. Here. So the second sentence, the third sentence, and so on and so forth. This is the last sentence. The term chatbot was already coined by yada yada yada. Then word tokens. What are word tokens? Word tokens are essentially the words that were extracted from this keyword. Sorry, from this entire corpus. So five words, four words. Chatbot from Wikipedia, colon the. So all these are word tokens. Now what I need to do is I need to perform some text processing step. What text processing? I told you about stemming, tokenization, lemmatization. I did the tokenization already. Let me do the lemmatization and removing the stop words. So I do lemmatization using wordnet lemmatizer, and it will return me the lemmatized form of tokens, which will then go and it will remove all the stop words or the punctuations like comma. So we don't need comma. This is not an information that I am having in my text, right? We don't need all these are not informative. So what we do is we will clean our word tokens for these unnecessary words that is present, and we will translate and we will remove the punctuation, and we will define these two functions which will perform this step of lemmatization. After that, we will define certain greeting functions. So for every chatbot, we need to start the conversation by some greeting responses and greeting inputs. So say, for example, user typed in, hi, hello, what's up, how are you? The bot can reply, hi, hey there, there. So for every word in greet dot sentence, the user that will input, it will convert that word lower. It will convert user input to lower form, and it will then compare with the greet inputs. If any of the user provided input is present in greet input tuple, it will then return a response, which is a random choice from the tuple that I have created as greet responses. So again, let me run this. What, what? Yeah, I was able to run it. Then comes the intelligence of the bot. So for intelligence of the bot, what I'm doing is I'm using cosine similarity and TF-IDF vectorizer. Guys who are not from ML background, a term frequency inverse document frequency is a way of converting your text or your word into a number, and these numbers are what machine learning models learn from. You cannot make a model learn from text directly. You need to convert your text into a numeric representation. So that numeric vector is what is term frequency inverse document frequency. And it gives more weightage or more value or more strength to those words in your document, which occurs very rarely or very. Hey, hi Kamal. I'm happy that you joined, but the session is already, running since last 1 hour, 15 minutes. So we are talking about NLTK chatbot. Guys, so term frequency, inverse document frequency vectorizer basically going to give more importance to the keywords which are rarely seen in a document and is not very frequent within the document. Rarely seen across the documents and not very frequent within the document. And cosine similarity is basically a way of measuring the similarity of two sentences or two vectors. My bad. So here the sentences are going to get converted into vectors, and these are sklearn, implementations which I'm going to borrow and import in my code. Now I have defined a function called response. So this function basically is going to generate a response to every user input. Now what it is going to do is it is going to take the user input. It performs a tokenization using, lem normalized tokenizer, which I have just declared above. Then it is going to handle the stop words by a default of English stop words. So any stop words that is present in English language is going to be used by default to clean my text or clean user's text. Then it is going to fit a transform and convert everything into TF-IDF vector. Post I have all the TF-IDF vectors, I'm going to do a cosine similarity on top of it. And on after that, after finding the cosine similarity, I am finding the most similar. I'm first doing a sort, and then I am returning the most similar or the first element or the zeroth in Python within the set of values, and the second argument from the back, the second argument to it. Then I'm going to flatten the vals, and I'm again going to sort it all the values, and finally I'm going to return the response if it is not able to learn, if the requested TF-IDF is zero, is not is is not present in the is the first element in the list, then it is returning a response that, hey, I'm not able to understand you. In other case, if it is able to resolve the input by the user to any of the text which is present in the corpus that I have created, it will return the sentence token as the response to the user's input. Now, at the end, I am defining the chat flow of the entire code. How exactly I'm defining the chat flow? I'm first creating a flag as true. And with this, the bot will start by saying, hello, I'm learning bot. Start typing your text here. Let's call it retrieval learning bot. Retrieval learning bot. Start typing your text here. Cool. Fine. So here is my chat flow, or exactly the bot flow. Again, I told you, right? Even if you create an AI chatbot, you need to code certain rules about how you create and how end the conversation. So this is what I'm doing here. I'm starting the entire flow by setting the flag as true in the beginning. Then I'm printing the bot statement, which is going to tell the user what exactly this bot can do. So it is telling that, hey, I'm retrieval learning bot, and start typing your text after greeting to talk to me. For ending corpo, type bye, right? Where exactly is greeting? I have defined a rule about greet, right, in the beginning in this function. So if the user will type saying hi, it will return a response with any of the random values inside these tuple. Hi, hey, hey there. Then what happens is the user response or the user input. So if the flag is true, for sure, Kamal, the recording shall be shared with you. While the flag will be true, the user input is taken and user input is converted into lower. If the user response is not equal to by, then or if the user responses thank you or thanks, then bot will reply as you are welcome and flag will be false and conversation will end. Else, if the user will greet, then bot will return with greeting the user. In any other case, the sentence token will get appended with user response. And for the sentence token, the word tokens will be found and final words will be chosen. And for the final word, the response will be generated by the bot or by the logic using cosine similarity and will be returned to the user. And hence, and at the end, I will be removing the user response from the sentence token in order to ensure that the my corpus is not corrupted or not, polluted. So let me start by running this. And finally, I have a goodbye statement saying that if nothing matches, just say goodbye. So hello, it begins by saying, hello, I'm the retrieval learning bot. Start typing your text after greeting to me. Let's say hi. What is the response? Bot is saying they're there. Alrighty. Cosine similarity will find the text similarity from the Wikipedia text. Yes. So I have already converted Wikipedia text to individual sentences by doing sentence, and not just individual sentences, but also I have lemmatized it to individual words. So across all the sentence, each and every sentence will get evaluated using the bag of words and the word vectors, and then it will return the most similar sentence for the user. So now what you am going to talk about. So I read about chatbots, right? Let me find about a sentence. What about Turing test? Let's read about Turing test. Okay. Can you tell me about Turing test? Okay. Right. Uh, okay. It is returning chatbot competitions focus on the Turing test or more specific goals. So it is going to tell you that for every, so it told you, right, that the chatbot competition focuses on Turing test or more for specific goals. You saw this? I didn't code this rule. The bot learned it automatically using the similarity. So it evaluated my sentence. Can you tell me about Turing test? And it said that, hey, you know what? The most important Turing test. So whatever response you return should contain Turing test, at least if in case you find it in the word corpus, and it will return it. Let's ask about what is universe. Let's type the keyword universe. Let's see if there is anything. Okay, bot is saying, I'm sorry, unable to understand you. Because you know what? The bot has not learned from the chatbot Wikipedia page anything about universe. What if you make a bot which is intelligent? Please, can you please type again Turing test and result will be same, or it will be a random choice. Okay, cool. What was my, can you tell me more about Turing test? For sure. Let's do this. It's a good question. Chatbot competition, focus on Turing test or more specific goals. ALL, my bad. There is nothing like Alan. Alan Turing and Turing test. Cool. Let's see what is the response. Oh, yeah. Again, it is fortunately matching to the same response. But the point is, when you have user input that is different, there might be difference in the word. But if for the same user input, the response is going to be same because the bag of words is matched from the user input, and then you're matching it to the corpus that you have. And finally, if I will type by, it should do something. Goodbye. Similarity, we can code to search on Google in real time. Yes, you can, Rahul. This is where the bot becomes intelligent. You can write a request library or a bot that can scroll over internet, fetch all the text corpus, and keep on appending inside this file, data.txt. And you can become more intelligent. But the thing is, you also need to deploy your code on a very powerful compute machine because you will be doing text matching on a big corpus. So this is it. This is NLTK demonstrated in Python. This is my code. And here you go. You have NLTK making a bot, which is very intelligent. You can actually talk to it. Now let's again repeat this. This time not with chatbot, but what about universe? Let's see how it goes. Let's copy everything. Do a control C. Let me create the new data file. Do a control A. Delete everything. Paste everything. And save the file. I'm again going to re-upload the file Let me be double sure by deleting this. I am uploading again data.txt. File is getting uploaded. Cool. Amazing. So again, these libraries are not important, but this is important. Now my raw doc will be, this is a good article. Galaxies, universe, dark energy. Amazing. All these I don't need, but I need to convert my raw doc. Oh wait, the raw doc dot lower, I need this. Then I need to convert everything in the raw doc to tokens. You have sentence token, you have word token. I need not define the lemmatizer. I need not define the greeting input. I need not define these functions. But yes, I can start the chatbot again. Hello, I am Retrieval Learning Bot. Start typing your text. So let me again say by saying, hey to this bot. The bot replies by saying, I'm sorry. Oh, wait, is it capital Hey? H-E-double-L-O. Bot replies by saying, there. Can you tell me about universe? Universe. What it says? One universe or many? Okay. Multiple universes. One universe or many. What is dark energy? It returns dark energy. So I wrote direct energy, it converted it to basic form, and it returned dark energy. Is there anything good that I talk about? Let's talk about Milky Way. Let's see what it returns. What is Milky Way? How large is the Milky Way is what it returns. So you see, it understands and it kind of knows what you're talking about. But again, it is not intelligent. I have just used a very noob or very basic way of, yes, exactly. It is returning the first match only. It is not having any context around it. It is returning first match based on cosine similarity. And hence, since it does not have any context around it, it is not intelligent enough. But you guys understood the framework on which you can make a chatbot. The way you can make it more intelligent is by playing around with more ML techniques of creating the word cloud intelligently, more around framing the initial sentences, understanding the user perspective, and keep training on it so that, rather than just having a single loop, you can take feedback from the user and you can understand if he's satisfied with the response or not, and keep on trying out multiple iterations until those models will be way more intelligent compared to the cosine similarity that I've used. Sorry, the TF-IDF that I've used. You can use word to vec too. That's all. This is my demonstration on chatbots. We are already on time.
So thank you guys. Thank you so much. Bye bye and have a nice day.